Hello everyone, welcome to Wi-Fi Learn. In this video, we can see about nodal analysis problems. In nodal analysis, there are 4 steps. That is, first step is find out the number of principal nodes and name it. In second step, take any one of the principal node as a reference. The reference node must be grounded. And the third step, find out the nodal equations in terms of KCL and Ohm's law by using KCL and Ohm's law. And the fourth step, solve those nodal equation and find out the node voltages and branch currents. Okay, let's move on to this problem. Solve the circuit using the nodal voltage method. So, this is a network having two principal nodes. Assume this as a principal node 1 and this as principal node 2. I am taking the second node as a reference node. Reference node must be grounded. So, it is ground. This is a principal node 1. Here, assume this is in a higher potential. So, current would be leaving. You have to assume the node which you are taking in that is in higher potential. If it is in higher potential, then the supply will go from higher to lower potential. Whatever may be the voltage of in the network, but you have to assume that node must in higher potential. Okay, so that the current would be leaving towards a lower potential. This is a current I1, I2, and this is a current I3. You are just assuming. So, the current would be directed towards the ground, You apply KCL in the first node, KCL at node 1. So, here there is only two nodes, one is grounded and you will get equations of for another node only. So, if you apply KCL in this node, sum of the incoming current is equal to sum of the outgoing current, or sum of the incoming current subtraction of outgoing current would be equal to 0. So, I1 plus I2 plus I3 is equal to 0. On applying KCL, we will get the equation as I1 plus I2 plus I3 equal to 0. I1 is the current which is flowing through this branch, I2 is the current which is flowing to this branch, and I3 is the current which is flowing in the middle branch. So, I1 can be given by the voltage. Assume this node at the potential of V1. This node is at the potential of V1. So, I1 current can be given by, according to Ohm's law, voltage divided by current. Here this branch is under the potential difference of V1 and 20. You are assuming this voltage is in higher potential. So, this branch voltage can be given by V1 minus 20 divided by 5. This is the current I1 value. I2 current can be given by V1 minus 8 divided by 2. So, this branch is under the potential difference of V1 and 8. So, I2 can be given by V1 minus 8 divided by 2. I3 can be given by V1 divided by 10. Since it is grounded, your value of the voltage would be 0 here, which is equal to 0. On solving this equation, you will get 2 into V1 minus 20 divided by 10 plus V1 divided by 10 plus 5 into V1 minus 8 divided by 10 is equal to 0. On solving this equation, you will get V1 as 10 voltage. V1 as 10 voltage. So, if you substitute V1 in these values of I1, I2 and I3, you will get the value of current, branch currents. So, I1 can be given by V1 minus 20 divided by 5. Right? I1 is written as V1 minus 20 divided by 5. Your V1 value is 10 minus 20 divided by 5, which is equal to, your value of I1 is minus 5 ampere. Your value of I1 is minus 5 ampere. This negative sign denotes your assumed current flowing toward in this direction. but your answer is negative. So your assumption is wrong. Current is actually flowing in this direction only. Right? Understood? You have assumed that current is flowing from this potential to this potential. You made an assumption, but you got the current value in negative. So the current is actually moving in towards upward direction, not in the downward direction in the case of this branch. Okay? I2 current can be given by V1 minus 8 divided by 2. Your V1 is 10. So I2 value is 1 ampere, which is positive. Your assumption which you made is correct, that 1 ampere current is flowing downwards. I3 can be given by V1 by 10, which is equal to 10 by 10, 1 ampere current. It is also positive. What you made an assumption is right. So 1 ampere current is flowing downwards. If the value of the current which you found comes as negative in the sense, you made an assumption that the current has been flowed from lower to higher. Okay? But actually the current is flowing from higher to lower. Okay? See the second problem. Solve the network by using a nodal voltage method. It is similar to the last problem only. First, find out the number of principal nodes. Principal nodes are 1 and 2. It has only 2 principal nodes. Okay. Take any one of the nodes as reference node. I am taking this node as a reference, which is grounded. So the number of equations which you will get only for this node. So the number of equations is only 1. Okay. If the principal nodes are 3 and you will take one node as a reference node, so you have to write an equation for 2 nodes. Okay. So the number of equation would be 2. You have taken this node. Assume the voltage across this node would be V1. Assume the voltage across this node would be V1, and this is in higher potential. This node is in higher potential. If this is in higher potential, obviously your current will be flowing downwards. You are making an assumption that this V1 is in higher potential, so definitely the current would be leaving these lines. So these are the currents I1, I2, I3 and I4. The current leaving the branches I have named as I1, I2, I3 and I4. Now according to KCL, sum of the outgoing current would be equal to sum of the incoming current. So I1 plus I2 plus I3 plus I4 is equal to 0. I1 is the current flowing in first branch. That is the difference between these two voltages divided by the resistance. So V1 minus 60 divided by 7 is I1 plus V1 divided by 12. Here it is grounded, so the voltage difference is 0. And V1 divided by 6 and V1 divided by 12, which is equal to 0. So this equation can be rewritten as, by using calculations, 12V1 minus 720 plus 7V1 plus 14V1 plus 7V1 divided by 84, your LCM value. So on doing this calculation, you will get the V1 value as 18 volt. Get a V1 value as 18 volt. Here, find out the value of the I1 now. You got the value of V1, right? So I1 is equal to V1 minus 60 divided by 7. Your V1 value is 18 minus 60 divided by 7. You will get the I1 value as 6 ampere. Minus 6 ampere. This negative sign shows that your assumptions made according to the current direction is wrong. So actually I1 current is flowing upward, right? 6 ampere this current is going this way, and this current will divide as I2, I3 and I4. Okay, this 6 ampere current will flow here and it will divide as I2, I3 and I4. So you will get I1 would be equal to I2 plus I3 plus I4. Okay. After finding the value of I1, I1 is equal to minus 6 ampere. So I1 is flowing in this direction of positive 6. If I1 is coming in this direction, it will be of negative 6. So this I1 is dividing as I2, I3 and I4. This I2, I3 and I4 could be found by normal current division method, or we can find by using this also. This I2 is equal to the current flowing V1 divided by 12. V1 is 18 divided by 12, which will get us 3 divided by 2 of 1.5 ampere value of I2. Your I3 is V1 divided by 6. V1 is 18. 18 divided by 3 is 3 ampere. Your I4 is V1 divided by 12. Again your I4 value is 1.5. If you add everything, you will get as 6 ampere. So I1 is 6. Your I2 value is 1.5 plus 3 plus 1.5, totally again 6. So sum of the incoming current is equal to sum of the total outgoing current, I2 plus I3 plus I4. Okay, understood? I hope you understood the concept of these problems. If you have any doubt, please leave it in the comment section. And if you like the video, please like, share and subscribe to Wi-Fi Learn. Thanks for watching the video.